Okay? So we have the limit. So if we make sure the subintervals are all the same width, right? So think of the rectangles. Remember the rectangles? Some of the questions had equal subintervals, so they all had to be the same width. So picture that in your head. Okay? As we increase the number of rectangles to infinity, so that's where the limit comes in. So picture I did a problem with, so let me look at one that we did last week, or yeah, okay. Right, so let's take one of these. We wanted to find area from 1 to 3, right? And we use the three rectangular methods, right? So let's picture that each of these rectangles was half a unit wide. Half a unit, half a unit, half a unit. Now let's picture that same area, 1 to 3, but I make more rectangles. So instead of half a unit, a quarter unit. A quarter unit. Would that do a better job or a worse job of covering that area?
Better.
Better, right? So now instead of a quarter, let's make it half of that. Right? An eighth. Thinner. Would that do a better job or a worse job?
Better.
Every time I make the rectangles, bring them in so their width is small, it gets smaller and smaller, I'm covering more of this area that I didn't cover before, right? So in a perfect world, if I keep doing that, I'll have the exact area. So that's when this part comes in right here. That's why the limit as n approaches infinity, the limit as I increase the number of rectangles. Because in a perfect world, if I had an infinite number of rectangles, I could get that area perfectly. Don't go over at all, don't go under at all, it would be perfect, right? So that's where this limit comes in. The number of rectangles, right? The E, the Greek letter that looks like E.
Sigma.
It's sigma, right? What does it refer to in math? When you see it in math, it always means we're going to do what? Summation. It's a summation notation, right? We're going to add up. So if you see this sigma, it's the Greek letter sigma. In math, anytime you see that, that means we're going to be doing some adding. Total. We're going to need a total. It's called a summation notation because we find sums. Okay? So let me write this down. The bottom is where we start. The top is where we end. Okay? So here, let's write this down. So this part right here, refers to the number of rectangles needed to cover the area, right? In a perfect world, I'd have an infinite number of rectangles, which I can cover the area perfectly. Don't go over, don't go under. Perfect, right? We just said this is a summation notation, right? This is going to tell us the total area, right? If we add them all up, that tells us the total area, right? Summation, the sigma, the Greek letter sigma in math means we're going to add things up. This guy here that looks like a curse word, it's not a curse word, it's not a curse word, but that is the function. What is the function f of x? What does that determine about the rectangle? It doesn't determine the number, right? How many rectangles? Think of when we did a table, when we made a table, right? The top was x, the bottom was f of x. What did f of x determine? The height of the rectangle. So that's going to be the height. I spelled height wrong. Of each rectangle. So we know, so this tells us the number of rectangles we need. This tells us how we're going to do. We're going to add them all up. This tells us the height of the rectangles. What am I missing? X. What does X refer to? X refer to, so if you have a rectangle, I need to find the area of that guy. So I know I need to add up some numbers. I need one rectangle because there's one there. I'll give you the height. What else do you need to find area? The width, right? The width. That's what delta X refers to. The change in X. Change in X refers to the width of each rectangle. Okay. We don't write it like that. You're not going to see it like that very often, except in a textbook. We write it like this. But this has each of those components. This has each of those components. Okay? So I'm going to break it down here. This little symbol right here, the integration symbol or antiderivative symbol, that's going to refer to the total area. So that means we're going to be adding things up. Okay? The bounds tell us how many rectangles we're going to need. The bounds tell us how many rectangles we're going to need. Here's the function here, f of x. We're used to seeing it as f of x. That dx part, remember that dx part that's always there that I said don't worry about, just keep writing? It's actually important. Darn. Because it tells us the width. Without that, how can I find the area of a rectangle? Without knowing the width, how can I find area? Right? How can I find area? You can't. Impossible to find area of a rectangle without the height or the length, whatever you want to call it, and the width. So that's why that dx is there. Delta x, the triangle is a Greek symbol, delta, change, it means a change in, right? A change in x. How wide are each of the rectangles? Okay? So how do we read it? We read the above as the integral. The integral is the red part. The integral of the function f of x from where? From the bottom to the top, from a to b. From the bottom to the top. So the bottom is always going to be the lower number. The top is always going to be the higher number. Because we start at A and go to B. Okay, so you're going to be seeing that symbol a lot. So that's what each part means. Okay? All right. So let's go to the back. So we're integrating. We are finding area under the curve. So for today, what we're going to do is we're going to draw what the graph looks like. Okay, we're going to draw what the graph looks like because that's the only method besides approximating that we know how to do. Okay? All right, so this guy here starts at 2, goes to 9. Right? The function is 3, and then you know what the dx part is, the width, right? So we need a graph. What is the graph going to go from? What number to what number?
2 to 9.
2 to 9. 2 to 9. What's the function? 3, right? So what does that mean? What does a function of 3 mean? It's a straight line, yeah. It always is 3. So everywhere the function is 3. So if it's at 2, y is going to be 3. At 9, y is going to be 3. Everywhere in between, y is going to be 3. That's what that means. Okay? So it's going to be a horizontal line forever and ever and ever. But I only care within the bounds. The bounds are 2 to 9. So my job now is to find area under the curve. What shape is that? It's a rectangle. It's a 7 by 3 rectangle. That area is 21. So the area under the curve for this guy is 21. Without drawing that picture, you probably would never have known that it was a rectangle. Okay? All right. A long time ago, probably in August sometime, I said in this class, if you ever get a question, doesn't matter which question, and it involves absolute value, draw a picture. Okay? Don't try to do don't try to use a rule or anything like that. Simply draw a picture. It will be so much easier when you do it that way. Okay? This one is the same as that. There's no difference. So we go from -2 to +1. Draw a picture. At -2, where would the y be? When x is -2, what is y?
2.
+2, because it's absolute value, right? Absolute value means distance from 0. So if x is at -2, how far away am I away from 0? You're 2. So make a dot. When x is -1, what is y? 1, right? At -1, I'm 1 step away from 0. At 0, if I plug in 0 for x to the function, what would I get? 0. If I had 0, you're 0 steps away from 0. How about +1? If I plug in +1 to the function, what do I get? 1. +1. Okay? So, makes a V. Area under the curve means from the function to the x value, or to the x-axis. When I say area under the curve, I mean from the function to the x-axis. That's that green right there. Well, each of those green are a triangle, right? Triangle. Area of a triangle, base times height divided by 2, or 1/2 base times height. So the first one here, let's see, it's got a base of 2. It's got a height of 2 divided by 2. 4 divided by 2 makes 2. The other triangle is 1 by 1. 1 times 1 divided by 2. 1/2. 1/2 unit. So one triangle is 2 units. One triangle, the area of one triangle is 2 units. The area of another triangle is 1/2. So 2.5, 3 over 2, or no, wait, would it be 5 over 2? Either of those is okay. Okay. Anytime you get absolute value, draw a picture. Draw a picture because it's always going to be easier than using any rules. We can use the rules, but it's just a lot harder when it's absolute value, because absolute value kind of does its own thing.
Oh, no.
Okay. Square root. Square root. Well, square roots kind of make a curve. Any square root, they kind of do one of these. They're curve functions. That's how positive square roots look. Negative square roots look like that. So it's going to be the one to the left. Okay. So let's draw a picture. So we need to go from -3 to +3. -3, -2, -1, +1, +2, +3. 1, 2, 3, 4, 5. Okay. So here's the function. That's f of x. So when I plug in -3 into the function, what am I going to get? not 9.
Minus 9.
9 minus 9 is, what's the square root of 0? 0.
I thought you were trying to trick us.
Okay. I'm not going to plug in -2 because that's going to give me something kind of in between. Let's do 0 now. Let's do 0. We'll come back to those. Let's do 0. When I plug in 0, what do I get? 3, because 9 minus 0 is 9. Square root is 3. So let's look at 3 now. Square root would be 0, which is 0, right? So let's go back into those ones that
Oh, man.
it's going to be a curve. So we're going to do the best we can with the graph. Remember, the graph isn't exact, right? So the square root, so if I plug in -2, right? That would be 4, the square root of 5. So the square root of 5 is approximately what? How close can you get with the square root of 5?
2.
A little over 2, right? A little over 2. So let's go make a dot a little over 2. Okay. If I were to plug in -1 into the function, I would get square root 8.
Just below 3, I guess.
A little under 3. A little under 3. So this would be... Okay. If I plugged in 1, I would get the same answer as -1. A little under 3. And then if I plug in 2, I would get the same answer as -2, a little more than 4, or sorry, a little more than 2. This shape, it's not drawn to scale, but it's actually a half circle.
Oh, no.
How do I know it's a half circle? Like, how can you prove or show me that's right now it's not drawn to scale. So it kind of looks like an oval maybe, a curve, but how do I know it's going to be a half circle? What's the definition of a circle? How do you know something is a circle?
Circle.
From the center, right? Every point on the circle is same distance from the center. So if I say the center is here, that's 3 units. That's 3 units. That's 3 units, right? And if I wanted to check this, I could use Pythagorean theorem to check it, right? It goes back to kind of the unit circle kind of thing. I'm not going to do that because I don't think you guys want to do that. But it's a half circle. Okay? Knowing that's important because now I can figure out area. So area from the function back to the x-axis. So area of a circle, regular circle, is pi times the radius squared, right? Well, area of a half circle would just be divided by 2. Okay, so pi, what's the radius? 3, right? Squared divided by 2.
5 times 9, guys. Have fun.
So 9 pi over 2. Yep. So for A, B, and C, those are all exact. Those aren't approximated.
No.
Area, all of those answers are exact answers. Okay, none of them are approximated like we did last week. Okay. All right, so this one, they already drew the picture for you. And a couple things here. It's yellow on mine, but I understand it's not yellow on yours. But this is really important. So let's say our functions have all been above the x-axis. So we just shade down, right? What if our function, because look at the function here. That part there is not below the x-axis. So how can I shade down to the x-axis? You can't, right? So when it's below the x-axis, you're actually going to shade up. Yeah, you're going to shade up. And any area under the x-axis is always negative. Always negative. Okay? So this goes from -8 to 2. That's what the integral says, from -8 to 2. So let's draw, I'm going to draw the bounds. To positive 2. So we don't go all the way to the end, we just go right there.
Why did they draw a little thing?
So above the x-axis, this is where the function's above the x-axis. So all of this area in green is going to be positive because it's above the x-axis.
That is a shape.
And all of the area below the x-axis is going to be negative.
He made a shape.
That's a shape.
Okay, I understand.
Okay. And then you're going to add them together and see what you get. So let's do the easy one first. The easy one's the triangle. Base times height divided by 2.
All right.
So it goes from -8 to -4.
Oh,
Height,
8.
8 divided by 2, right? So that's 32 divided by 2, so that's 16.
Okay.
That area is not 16, though. It is
Nice.
-16 minus 16, however you want to think about it.
We're are you right? 16.
Okay. Now the green is not any kind of shape I recognize.
I don't think anyone recognizes.
So I'm going to do this. I'm going to do this. This is the way I would do it. There's many different ways that I know that I can do it, but I'm going to do it this way. So what I'm going to do is I'm going to break this up into smaller little segments here. Okay, so I'm going to find the area of this little triangle here. So it's a 2 by 4, right? 2 by 4 divided by, what is that, 1? Oh, it's not divided by 8.
Divided by 8.
Divided by 2, so it's going to be 4, right?
Wow.
So this positive 4. I'll write it
That's
in
such
bullet.
a shape. Can we just find the radius of the part?
Exactly. That's what we're going to do. Exactly. That's what I'm going to do. That's the way. They told me that there's a semicircle here, so this guy here is a semicircle. Okay? So what I'm going to do here, this is what I'm going to do. This is the easiest way that I see it, is I'm going to close off this shape here, and then subtract this part from it, and then that's the answer. That's what I'm going to do. Okay? So if I were to close off this, that would be a 1, 2, 3, 4 by 1, 2, 3, 4. It's a square, right?
Yeah, it's 16.
So 4 by 4, so it'd be 16, right? So let me write this down.
Whatever that is.
And then now I'm going to find the area of this red right here.
Wait a minute, that's a pi.
That's a half circle, right? So what's the area?
Pi times r
Pi times r squared, right?
over 2.
Over 2. So what is the radius of that red circle, half circle there? 2.
Okay, so it's 2 pi.
So we have 16 minus 4 pi over 2, which is 16 minus 2 pi, right? That guy is right there. Okay, so now we have all 3 areas, the 2 greens and then the pink down here. So we got to add them all together. Not subtract them, add them all together. Okay, so here we go. So the area from -8 to 2 for the function dx equals, the first one is -16, right?
Yes.
Plus
16. 4.
4, right? Plus 16 minus 2 pi.
Is it?
Combine like terms? We could combine some like terms, right?
Okay, we can.
16 minus 16 is 0. So we got 4 minus 2 pi. Done. You can divide it by 2 if you want. You could have 2 times 2 minus pi. You could have that. That's okay. But that's as far as you need to go. Believe it or not, the first quiz that we take every year, this is the problem that's missed the most. Okay? And it has to do with the signs. Signs. Sometimes people leave this part positive 16, they forget to change it. Sometimes they get this part wrong. This is the one that's incorrect the most often. Okay, so just be careful with those. Okay. Okay. All right, so what I want you to do is to do the next example. I'm not sure if it's number 3. Yeah, it's number 3. Sometimes they're labeled wrong. So I want you to graph that guy. If you don't know how to graph it, draw an X and a Y. If you don't know what that's going to look like, draw a table. X and Y, plug in numbers, make dots. So I want you to draw the graph first. So the function is this guy here. So we're going from 4 to 8. So if you don't know where to start, where do I make a dot at 4? Where do I make a dot at 5, 6, 7, 8? Where do I make dots at? Use the function to tell me. Some of them are going to be positive, some of them are going to be negative.
This guy's way too much. That's what you need to go through. That is a lot of negative area.
So from 4, when I plug in 4 to the function, I get 3 minus 4, which is negative 1. So 4, negative 1, make a dot. 5, it's going to be negative 2. 6 is going to be negative 3. It's linear. If you knew that, you just needed to find the pattern. So my area goes from here to there. So I'm below the x-axis, so which way do I shade? Up or down? Up. Always shade back towards the x-axis, wherever that is. Always shade back to the x-axis. So if you're below, you shade up. If you're above, you shade down. That's a shape we've seen before. We saw last week. It's a trapezoid. That's a trapezoid. So area of a trapezoid is 1/2 base 1 plus base 2 times the height. How do you know where base 1 and base 2 are? They're parallel ones. Those are the two that are parallel. So base 1 and base 2 are always going to be parallel. So base 1, base 2. And it doesn't matter which one's base 1 and which one's base 2 because you're adding them. So you can call the small one base 1, you can call the big one base 1. It doesn't matter what you call it. Just add them together. So this is going to be 1/2. So 1 plus 5 times. And then the height is always directly across from the diagonal side. So this is the diagonal side here. So directly across, it would be from 4 to 8. It's the width. Okay. So 1/2 times 6 is 3, times 4 is 12. So if you put 12, you'd get it wrong. Why? It's got to have the negative sign. Got to have the negative sign, yep. Okay.
Why are you telling me? I'm not the teacher.
What's the difference between A and B? Kind of a trick question. There's no difference. There's no difference.
I'm like, wait a minute.
One is just in words. One is using the integral. No difference. I always do both just to make sure you understand what you're doing. Okay.
What do you mean balance from pi to 2 pi?
So the last thing we're going to do, oh yeah, we got plenty of time, is to do a trig one. Pick the easiest trig one. Sine is the easiest trig.
You got it, Archie.
Most of the integration you're going to do is sine and cosine. Very rarely is it tangent or cotangent, or I don't think I remember seeing things like that. Okay? So they've given us a piece. They've given us a piece of the answer. They said,
Hey, that's 0 to pi.
0 to pi, it's 2. Area is 2. Okay? So what I'm going to do is I'm going to draw a picture. I'm going to find some open area here. I'm going to draw a picture of what they've given me. Because they all revolve around the same kind of, they're all very close. So it's positive, let's see. So positive 1 to negative 1. So for sine, I'm going to put pi over 2. I'm just going to put the big ones. I'm not going to put the in between. 3 pi over 2, 2 pi. Okay, so sine of 0 is 0. Pi over 2, sine of pi over 2 is positive 1. Sine of pi is 0 again. Then we go to the negatives, right? And then we finish one cycle at 0. Now, the green is not what they've given me, right? The green is not that whole thing. The green is just the first half. So that's the green there. And they've said, hey, area there is positive 2. But we know that cosine keeps going, or sine keeps going. Okay, so we're going to leave it like that. So far that's the given part. The green is 2. Area of the green is positive 2. Okay, so A, how is A different than the green?
A is from pi to 2 pi.
Yeah, it just shifted over, right? So now it's from pi to 2 pi. So that is here. Take a wild guess. What do you think the area of the pink's going to be? Negative 2, because it is symmetrical. Because those areas are symmetrical. So this is going to be negative 2. So the area from pi to 2 pi is going to be negative 2. What's the area of sine of x from 0 to 2 pi? 0, because I'm taking the green and I'm adding the pink, and they cancel each other out. So sometimes what happens is when you see an answer of 0, you think, oh, there's no area. No, they just cancel each other out. So just because there's no area doesn't mean that, or 0 area doesn't mean there was no area. Okay, so don't get those confused. Okay, so the next one. 0 to pi over 2. Yeah, it's symmetrical. So it's just half of the green. Right? They all have the same values going up as they do going down. You can look on your green sheets. They all have the same values going up as they do going down. negative pi to positive pi. So I didn't draw the negatives, and I'm not going to, but let's look at, so from negative pi to pi, so I have the green. So from 0 to pi, but then I also have over here to the left, right? Well, where is it going to go? Down, right? If I was to draw it on the negatives, it would follow the pattern, right? It would go like this until I get to here. And isn't here negative pi? So what do you think the area of that guy would be? Negative 2, yeah. So what would the area be from negative pi to positive pi? It's the same answer as 0 to 2 pi. Because you get negative 2 plus 2. Again, it's not that there's no area, it's just that they cancel each other out. What is that 2 going to affect? Yes, vertical, right? It's going to move it up or down. Positive 2 means it's going to move it up. So that means all of those black dots are going to shift up 2 units. Shift up 2 units. So let me draw a picture of what's going to happen. And it's not all the way, it's just from 0 to pi, right? Okay, so let me draw a picture of what it's going to look like. Each of those dots, I think there's only 3 from 0 to pi, are going to move up 2 units, right? 1, 2, 3, 4. So at 0, it's not going to be 0 anymore, it's going to be 2. At pi over 2, it's not going to be 1 anymore, it's going to be 3. And then at pi, back to 2.
Okay.
So this shape is kind of like that.
Are we going to break it up, or are you going to do that too?
Okay. I already know some of this. What part of this area do I know?
Above 2.
Yeah, right here. It's not drawn to scale, so it doesn't look the same. That area is 2.
Oh no, what if 2 by pi?
And what did it create when I raised it?
Yeah. A rectangle.
A rectangle, right? A rectangle. It's 2 tall by width of pi. So 2 pi. So you're going to add what I already had plus what was created, and you're done. Why did that happen? Like Tia said, it was a vertical shift. Everything moved up 2. Everything moved up 2. If that was a negative 2, everything would have moved down 2. All the dots move up 2 because of that vertical shift. That's it. Okay. That's it. Shapes. Yep. All right.